Hello, I want to review a couple of concepts that are important in terms of pressure differences. So if I have a pipe and I measure a pressure difference, and let's say that I have this connected to a manometer, and I'm not a very good. So the manometer, let's say that it's mercury. This is the symbol for mercury, and so it'll tell me that there's a difference in elevation. Okay, so let's say that it says that it's 14.6 centimeters. The question is, what is the pressure, or the change in pressure? So remember that for pressure, the equation that relates any distance or depth to pressure is the density G times H. And that H and that rho are related because depending on the fluid, in this case is mercury, okay? So you have to look at the density of mercury, and this is the acceleration of gravity, or alternatively, look at the specific weight of mercury. Remember, the specific weight is rho times G. Okay, so let's say that the indicator fluid is mercury, or anything by that matter. So let's say that the specific gravity is 1.95. So what that means is that the density of the indicator fluid is 1.95 the density of water, okay? Or that the specific weight of the fluid is 1.95 times the specific weight of water, okay? So if I have 1.95, when I go to this expression for the change in pressure, then I say this change in pressure is going to be the density of the fluid here, right? And the density of the fluid is, or the specific weight, let's talk about the specific weight, 1.95. The specific weight of water, if you look at the tables, is 9,810 newtons per cubic meter, okay? And then you have 14.6 centimeters divided by 100 centimeters. So that change in pressure is going to be 2,792.9 newtons per square meter, okay? Or 2.8 kilonewtons per square meter. So are we clear on that? If not, make sure that you review this. So it can be any fluid. In this case, these are the indications. So now I want to relate that to an example problem that we discussed in class. So here I'm telling you the manometer indicates a pressure difference of 14.6 centimeters, and then this here is the indicator fluid. So these two parts are what you use to calculate the difference in pressure, right? And you need this difference in pressure to know what is the velocity. So that difference in pressure, and there's two ways of doing it, but I prefer to do it this way, would be again the fluid, or the manometer fluid, times the manometer fluid, and that's what we did. So we said it was 1.95 times 9,810 newtons per square meters times meters, okay? So this here was 2,792.9 newtons per square meter. So now I'm going to calculate the velocity. So this is two different parts to the problem. So the velocity is going to be equal to the square root of 2 times, this is metric 9.81 meters second square, and then now I have the change in pressure, 2,792.9 newtons square meters, and then here refers to the fluid that we have, which is water in this case. This is for water because the velocity here refers to the pipe and the water in the pipe. So it's 98.10 newtons per cubic meter. So the velocity is 2.36 meters per second.